Thank you very much for organizing this conference, and thank you very much for having me. Today, I'm going to present the productivity externality of remote work. With dramatic increase in remote work, there is some concern that more remote work reduces in-person interactions, and the society benefit less from on-site productivity spillover. However, to look at whether the implication of remote work on the social welfare, it's also important to check whether new technology could generate this productivity spillover that benefits all workers. An example of remote productivity spillover is that with more remote workers, one can use remote communication technology more effectively, and there could be more innovation about remote technologies and can improve one's productivity. So in this research, I explore how large is this remote productivity spillover and what's the implications on social welfare for achieving social optimal level of on-site work in presence of both two types of productivity spillovers. I built a quantitative model to answer these questions. In the model, workers can choose whether and how much to work from home or on-site based on the relative productivity and relative amenity of these two options. And there exists productivity spillover between and within remote and on-site workers. However, when workers make those choices, they will ignore this productivity spillover effect. So this leads to a gap between the social optimal level of work arrangement and the market equilibrium. And market equilibrium is decided by individual choices. So I matched the model to the data, and based on the quantification results, I find that the social optimum requires a bit more on-site work, but the existence of remote productivity spillover can bring the economy closer to the social optimal level. Then I will introduce how I model this spillover, how I estimate this spillover, and the quantification results. There are several empirical facts lay the foundation of the model. The first one is there exist variations across city and sectors in terms of remote work, both for the employment size and for share of time working from home for hybrid workers, as shown in this figure. And also we can observe the positive correlation between wages and employment size for both on-site and fully remote workers. And one of the possibilities that drives this pattern is that there may exist positive productivity spillover for both on-site and remote work, which leads to a higher productivity and higher wages. So in the model, similar to the literature, I assume more remote workers or more on-site workers leads to a higher on-site or remote productivity. And two elasticity govern the strengths of these two spillovers. And what's new to the literature is that I also allow the cross-work site spillover, which means more on-site workers may lead to a higher remote productivity. And a parameter tau governs the strength of this cross-work site spillover. To match this, estimate these spillovers, I match the model to the data. I'm using the US survey data, CPS and ACS from 2022 to 2024. And in the data, I can observe employment size for different work mode across different cities and sectors, and how much hybrid workers spend their time on-site or remotely. There are two parameters that are new to the literature. One is this remote productivity spillovers. To estimate these parameters, I use general method of moment that joint estimate several key parameters in the models. Here I will introduce the intuition to estimate this parameter. If there is no productivity spillover, we'll expect a downward sloping demand curve. However, if there exists positive spillover, we'll have an upward sloping demand curve, meaning more remote workers lead to a higher productivity and a higher wages. And to estimate the slope of this demand curve, I will leverage the shift from the supply side and leverage a moment condition where the supply side shifter and the demand side shifter are exogenous with each other. So the algorithm will pick a parameter such that the covariance of these two shifters are exogenous with each other. So when we have a covariance of these two shifters closer to 0, it's as if using the supply side shifter to estimate the slope of a demand curve. And another new parameter is this cross work size spillovers. And this parameter governs the slope of a relative demand curve, where on the x-axis we have the on-site timeshare, and in the y-axis we have the relative productivity. And if the cross work side labor contribute to the productivity the same as within work side labor, then how much hybrid workers spend time on-site or remotely will not affect the relative productivity of on-site and remote work. So similarly, to identify the slope of this curve, I use a shift from the supply side and impose a similar identification assumption where the shifter from the supply side and demand side are exogenous with each other. And based on this structural estimation results, I find that the remote spillover elasticity is relatively smaller than the on-site one, and the cross work side spillover is relatively small. And based on those estimations, I solve a social planner problems where social planners choose different employment and share of time working on-site for different city and sector to maximize the social welfare, and compare the social planner solution with the market equilibrium. And the market equilibrium is what we observe in the data. And I find that the result indicates a social planner could increase the welfare by 2% by encourage hybrid workers to spend 3% more time on on-site work and increase the on-site employment by 2%. And this can be achieved by providing an on-site subsidy equal to around 11% of hybrid workers' gross income. And then I run an experiment setting those remote spillover and cross-work side spillover to 0. And I find that if there is no remote spillover, to achieve similar level of welfare improvement, we'll have more changes and it costs more. And then I also calculate how much productivity change if hybrid workers spend more time on-site and remotely, which varies by different city and sector, and calculate the variations across city and sector, comparing the social optimal level of on-site work and a remote work. So to conclude, in this research, I use a model to estimate the remote and on-site spillover effects. And I find that at the extensive margin, which measures how much productivity change if there is more on-site or remote workers, the on-site spillover is stronger than the remote one. And the cross-work side spillover is relatively small. And based on this estimation results, I find that according to comparing the model prediction and the data, I find that the social planner will prefer a little bit more on-site work on average, but it varies across different cities and sectors. If there's no remote work spillover, to achieve similar level of welfare improvement, we'll need larger changes. Thank you very much. I'm looking forward to your comments.
I'm so happy you're working on it because it's super important. A few things, maybe this is in your paper, but it would be helpful to think about the nature of the remote work externality you have in mind. Two come to mind immediately, and they're very different in character. One is I avoid the negative externality of colleagues who waste time, or so if I go on site. So that's a static type externality. I'm not endorsing that as important. I'm just saying, just setting up as a counterpoint to something else that Nick and I and Julia had a bit of evidence on. We showed that the composition of new U.S. patent filings shifted towards technologies that support remote interactions in the wake of the pandemic. It's basically the share doubled. Now that is presumably going to increase the effectiveness of these remote technologies in the economy as a whole. That's a very different kind of externality. And I'm not sure what it is you seek to capture in your model. So maybe you can say a little bit more about the nature of the remote externalities you have in mind.
Yeah, sure. The nature of remote spillover I have in mind is more related to the innovation effects you just mentioned. And I think the decreasing in the negative spillover is also very interesting. The model does not really specifically specify the sources of these spillovers. I have that in explanation of why there is possibility of existence of this remote spillover. I think it's always good to think about those micro foundation.
I think maybe just building on Steve's point, I don't know if the model, if this would be tractable, but it'd be interesting to try to estimate those externality terms, and particularly the remote on-site externality terms, like over time, to see if the technologies have gotten better, and so now you do see more like agglomeration across these modalities.
Oh yeah, in the model the parameter does not vary by time, but I think it's always very interesting to look at the changes of those agglomeration or spillover effects over time, and it coincides with the changes of the technology we have today. And I think I can do this by leveraging more data structure. Although it's not a dynamic model, but I think it's good to estimate this.
No, but I think so. So one easy way of implementing Emma's suggestion could be, so you have one estimation with 2022 to 2024 data. If you repeat the estimation, and you're not going to have exactly the same data, but like using work from home numbers from say 2018, 2019, then you can see if you get a similar parameter from these two different estimations, and that can be very informative.
Oh, okay. Thank you very much.
So sorry, I guess we're all on the same, but I thought from the model side, the other way to do it, we go back to like the classic endogenous growth literature and have learning by doing. So if you think of some of those old models, you would have the productivity of on-site work. You know, a classic shortcut is that is a function of the amount of on-site work that's happened over history to some parameter, and that parameter is often less than 1. So it's not explosive, which is like the early learning by doing. You know, we saw Filippo, the Aguilar and Howard. Nope, it's this kind of thing. So you could have one for on-site and one for off-site. And when you start in 2020, there's been almost no off-site work historically. So the rate of progress of off-site is going to be much higher, because basically no one really remotely worked before 2020, so the technology was terrible. So the potential for improvement is much steeper. So it may actually be you want to have, you get, the social planner would say we should have more remote work initially to encourage the development of technology. So Zoom gets better and the AV gets better. And then because we've had so much improvement of on-site, in-person stuff. But that gets you have 2 extra state variables there, but that will be the one standard way of doing it in the model.
Okay. Thank you very much for those suggestions.
That's kind of
really
like what we have in the patent paper. It's the same idea.
It's what we appeal to.
Yeah, exactly. It's like, it's the whole learning by doing, like going all the way back to the Liberty Ships papers. There's a whole literature on learning, a massive literature that would be very much like this. Your productivity is a function of past activity.
Thank you. Thank you very much.
Yes. Thank you.
Good morning, everyone. Thank you for the organizers. I think it's a great opportunity. My name is Halil. I got my PhD from University of Minnesota this summer and joined Penn State as a visiting assistant professor. Here the title of my paper, Remote Work Implications for Optimal Income Taxation. Fraction of work from home is big enough to consider its implication over tax base. And as we know, like there have been productivity of work from home was a hot topic, and thanks to Nick's contribution, we even have information before pandemic. But there's a group of researchers saying the work from home could be associated with some productivity loss. I say that if they are correct and those effects somehow present, I claim this could matter for policy analysis, specifically for optimal income taxation. And regarding that, I raised the following question: how does work from home affect optimal income taxation? To answer it, I write a static generic curve model with endogenous workplace choice. In this environment, we have discrete choice like either work from home or on-site. I consider two-dimensional heterogeneity for amenity value of work from home and the skill of the workers. And finally, I solve planner problem with the Ramsey approach using a parametric income tax function. So idea in this paper, not excluding those many nice flavors either for work from home or other channels, I meant to keep it simple as much as possible to get a comparable result with the traditional method. That's the part of the contribution. We have a continuum of workers indexed with the theta and chi. Theta stands for skill, chi stands for the amenity value of work from home, drawn from independently from some non-distribution. I consider separable form of utility. In addition to consumption and hours, workers choose their workplace, which is indicated with R. And with the red mark, we see chi of R represents the amenity value of your workplace. That is normalized to on-site. So chi on-site is 0. Otherwise, chi as mentioned. So we have single consumption good here. That's produced by a representative firm with a linear technology. And workers allowed to choose their workplace. There is no any friction. If they work from home, there is some productivity loss with some non-technology, and they pay tax on their labor income. I consider this parametric form of the tax function, and I will mention more about later. A nice feature of additive form of the amenity value brings this nice result, which is very simple but intuitive. So optimal workplace choice follows a threshold property. What is that? An individual work from home if and only if their amenities are large enough. And plot simply shows that in the x-axis we have skill, and in the y-axis we have corresponding threshold. And as we see, the curve is decreasing. The area above the curve represents the fraction of work from home for corresponding skill level. And what's the takeaway here is that, so we have a selection to highly skilled guys to work from home, which is the parallel in the data. So what? Like if with that much simple ingredients, if we think, why does work from home matter for optimal, for tax policy? So the mechanism allows us here, higher tax progressivity can lead higher work from home. And similarly, higher tax progressivity mitigates the distribution of workplace by across workplace. That means the distribution could be more even. And what should be the result then? I claim tax progressivity on labor income should be lower with work from home. And why? The elasticity of taxable income is higher with work from home environment compared to no work from home one. Is an example, everyone is working on site. This is a key reference point in the optimal income taxation literature. What is that? The concept like simply measure how responsive of the behavior of taxpayers for a little change in the tax policy. The math could be confusing. I want to tell the intuition like, so we have amenity value of workplace that's not taxed. I'm not saying anything normative, that's a fact. And we have positive selection to work from home. And with the lower productivity, all those forces together increase the sensitivity compared to no work from home one. And what is next? So we have finance, we need to finance the transfers and the government expenditure and using the features of the work from home in a calibrated economy with the US data. I solve planner problem with the Ramsey approach where we maximize utilitarian welfare by choosing the optimal tax progressivity, that's tau. In this form of the tax function that has been popular like in the recent years, like due to contribution of the Jonathan Hitko, Storlesen, and Violante. So what is that? The key parameter here is in the power, that's tau. That's the tax progressivity. In the traditional form, marginal tax stands for with the you see in this third bullet point, which is monotone in income. And to benefit from comparable feature of the environment, I solve the same problem for the no work from environment, like we are turning off the workplace choice. And here I want to summarize the results over the welfare function. We see the tax progressivity grid in the x-axis and welfare work corresponding tax progressivity on the y-axis. The blue one is for the work from environment, and red one is the no work from home one. So we see that the optimal policy is could be significantly lower. What is the interesting caveat here is that we see that welfare is lower. Naturally, like this could be comparing apple and pieces. Like we don't do that because they are two different environments. But an interesting caveat here is that we have some amenity value of workplace, and I force it to be non-negative. And what is that? The efficiency losses from those top guys are dominating those all positive welfare in the utility. That's the interesting result I want to share. And one nice feature of the model, like we have the tractable measure of work from in the environment. So the calibrated data for the progressivity is the 18% that I used, and so we have higher optimal value, and corresponding work from home share is higher. So what is that? As I mentioned, the progressivity can decrease the threshold. That means like work from home and leisure could be more attractive for people, specifically for the richer. I want to come this if questions are raised to sensitivity. I can conclude with the following slide. Work from home can reduce optimal marginal taxes on labor income, and this reduction is quantitatively significant. It is sensitive in scale, since the environment is very simple, but robust in the direction. So it is always lower. So if you have just 4% loss, 10% loss, the result we see in the first plot is always true. One contribution of the paper, simplified environment, delivers us to comparable results with the standard that can be obtained with the standard approach. And finally, since we have time constraint, I don't mention here, but in the paper I discuss taxation by workplace. It's a nice literature going back to 1970s, initiated by Akil. In the literature, we have a nice application that the marital status taxation, age-based taxation, or gender-based. So I propose a taxation by workplace, and with this mechanism, since we are providing one more information set to planner about the distribution of the workers, this leads higher welfare optimal policies. And thanks so much.
By the basic result, but you've tied it to controversial claims about productivity of the relative productivity from home. That's entirely inessential to the paper, and your point as I see it. You could just as well specify a model that allows for remote work to be more or less productive with some substitution between the two possibilities. It's like the functional form that we have in our paper with Jose and Nick on. That's not, the revised version is not yet out there. So there's no reason to tie your result to claims about what the productivity, relative productivity is. You can be entirely agnostic on that point. The same thing will still go through.
Exactly, I agree. Selection itself is already other angle that I'm currently considering.
Yeah. So I would just encourage you to restructure the model so that it's agnostic on that question about whether because the literature's all over the place. It depends on the job and so on. That's point one. Second, and less fundamental, but you might want to think about whether there are other externalities, external effects associated with the choice between work from home and not. And the obvious one that comes to mind is greater load on the transport system when everybody works in the office than when they don't. So you either need a greater investment in transport infrastructure, which is expensive, or you're going to have higher congestion costs. So that's kind of like a side issue. But there are other externalities that you might want to think about in this optimal tax problem.
Yes. Yeah. Thanks so much.
Thanks. Interesting. So two thoughts. One is on the tax on the workplace. You mean that you would tax the amenity value of working from home?
No, I don't mean that. So we are having different tax policies if you are working from home or on site. Okay. You know, you report when you're reporting like I work from home or on site.
Okay, implicitly you'll get. I was about to say it would be a weird thing to do, but there are other amenities that are taxed. For example, you're taxed for a company car. I think some places tax for free lunch. Healthcare pensions are untaxed up to some level. So it is not out of the ordinary to tax for some non-monetary amenities.
Yeah.
So I agree. I mean, it would be an unusual thing to do if possible. The other thought is, I thought from your title you're going in a different direction, which links to someone that presented last year, Daniel Aguilar, which is you could look at here, which is there's an issue about tax avoidance based on working in one place and living somewhere else.
Yeah.
So it could also be you could set up when you work from home, your tax rate is different because you're living in a different state.
Yeah.
So in the US, there's all these distortions, which is another angle, which is kind of interesting as well.
Yeah.
Which is a separate distortion you could pretty easily look at in this machinery.
Yeah, the local taxes are a really good point. In my third year paper, actually, I was working on this direction. And later, when I recognized the channel, actually, this is more broad. So it is, and I thought this is more interesting, and I went to this direction. But I have some preliminary work about that. The local dispersion in the tax progressivity across states are really interesting in the United States. Yeah.
Okay. I was very happy to see Minnesota meets work from home.
No, I was wondering if you can speak a little bit to the fact that you had something about the different valuation of the amenity, and I'm thinking about the populations that have sort of a bigger elasticity of labor supply, like women and maybe disabled workers who are actually brought in the labor force because of work from home, and maybe how that interplays with your.
Well, that's so true. Like as you see here, we have some laws. And we assume that it is decreasing the output in the direct pay. But it is actually not necessarily true. So what you are saying, and even for those guys, it is not realistic. So this benchmark is only for we can think this like the corner angle. So whatever we add there, it's going to decrease these differences. And positive angles like that also will contribute that. For instance, I don't change the labor elasticities by workplace there. Obviously, it is the case because some of the papers saying that those defending the lower productivity case, they measure productivity loss in unit in time. But in total output, they say output is decreasing a little bit, not much. So I'm definitely considering those positive angles as well as the externalities. Some of them are in my agenda and on purpose. Thanks so much.
My take on it is that you could have the stochastic fixed costs of work. Everyone draws it, and you're going to then have labor supply effects. I think the labor supply effects are probably bigger than productivity. It may well be the productivity is negative. We can argue about it, but the labor supply is clearly positive, and you'd find. And that also has welfare effects.
Yeah, definitely. Many nice micro foundations are like
because people pay positive tax, so there's a positive welfare effect of work.
Yeah. Higher employment for mothers or other many micro foundations definitely matter here. I agree. Okay, thanks so much.
Okay, wow. Hi everyone. I'm very glad to be presenting my joint work with my amazing co-authors Juan and Isabella from Columbia University. Let's get started. So I don't think I have to argue a lot that gender gaps in labor markets are very large, even in developed countries such as the US, which is going to be our focus today. And because of pioneering work by Claudia Golding, we know that a lot of this is due to the motherhood penalty. Now, me and my team like to think of this as fundamentally a problem of the household allocation. Let's think for my presentation that we are Gary Becker, and that we can think of a child and parenthood as, broadly speaking, a set of new constraints and challenges imposed on households that heavily incentivize household specialization, and hence you see, even if we may have small comparative advantages, at dealing with household specialization, you see these big changes in the whole of the economy, right? So since this is a remote work conference, we're going to be trying to argue that remote work could be a venue to relax these frictions between motherhood and work. And how we're going to differentiate ourselves is by arguing that by looking at this remote work, how it could be affecting spousal decision-making, and how does it affect the household as a unit. So the idea is that to drive this idea of spousal decision-making, we will be looking at how increasing the male spouse's availability at home could be affecting the division of childcare. And then by enabling a more equitable division of childcare, we could be seeing at how this could be increasing women labor supply, and thus we would be seeing how household specialization could be decreasing overall in the economy. So those are two big questions. We're asking whether shocks in remote work options for dual-parent households with young children could be improving specifically women labor market outcomes. And is this happening because there is a more equitable division of household tax and very specifically of childcare? How are we going to go about this? Is that we're going to be leveraging large variation in available jobs with remote work options across the US using the pandemic shock. And we're going to be using these shocks at the occupation level specifically to estimate an event study framework where we estimate the effect of the increased work from home options from one spouse on the other spouse's labor market outcomes. And just as a preview of the result, we see that spousal shocks will be increasing women labor supply, but the spousal shock on the woman has largely no effects on the outcomes that we are representing today on men's labor supply. And we also see that women and male both spouses are working from home more, and we see some patterns of spouses substituting childcare responsibilities, which largely suggests that there has been a decrease in household specialization. So what data are we going to be using? Our main data set for household outcomes is going to be the ACS. And for the household time use data, we're going to be using the available data that is in the US, which is the ATUS. And then we're going to be a bit of a rebel today, and we're not going to be using the Dingle-Neiman estimator for the teleworkability index. Instead, we're going to be relying on Nick and Steve's job posting data, which computes the monthly share of job openings online that have remote work options at the 3-digit occupation level. We're going to be using that as the basis for our shock. Our shock is very simple. We're going to be computing long-run differences in this average share of job openings with remote work options between the after-COVID period in 2023, 24, and 2019. To simplify the econometric analysis, we're going to transform this continuous shock into a binary shock where we're going to classify an occupation as treated if the other occupation shock is above the median. And then since we're interested in estimating the effect of the spousal work from home shock on women outcomes, we will be classifying a household as treated if the male spouse in that household works in one of our high exposed occupation as defined in this bullet. Our strategy is very simple. We're going to be using an event study framework, and we're going to be using our work from home shock, which is at the level of the male spouse occupation. And we're going to be interacting it with time dummies in the years surrounding the COVID pandemic, using 2019 as a base year. We're going to be adding fixed effects for state by time at the state by time level, and of course at the husband occupation level, and a handful of household level controls such as age of education of the spouses and the number of children. So essentially, we will be comparing the changes in outcomes for households where men work in occupations that saw very large changes in the availability of work from home options, in the jobs that offer work from home options, with households where the men work in occupations that largely didn't see a lot of changes, of which there are many. There's a lot of variation that we can see. We've seen graphs that show this variation in previous presentations. Of course, the essential assumption is one of parallel trends between these two household types. But even with that, we'd like to clarify that even if those assumptions hold, our betas are largely capturing two types of effect, which we call the spillover and the matching effect. The spillover is basically any increase in women's supply that is coming exactly from the men being more available at home. But then, because assortative matching is a thing, then a shock that increases the probability that a man works from home is also bound to shock the probability that a woman works from home. And so if we see an increase in the women labor supply, it could be coming from the women being more likely to work from home, even if the husband doesn't uptake work from home himself. We have a strategy to kind of differentiate the two. We're going to talk about that in a second. But having said all of this, let me just show you our main set of results on women labor market outcomes. We see that the spousal shocks are increasing women employment. At the extensive and intensive margins, we see an increase of 1 to 2%, up to 2 percentage points at the highest level for women, while wages seem to be increasing by some 5%. We also have a little bit of a quasi-first stage. This is a reduced form estimation, but we have a first stage where we see how does the shock on the husband occupation. Seeing the shock actually increases their uptake of work from home, and we see that it increases a lot with this type of shock. Men are doubling, maybe up to tripling the amount of work from home, or the probability that they'll be working from home using the ACA's data. In addition to that, to go more into the intensive margin, we see that the spousal shock is increasing women workly hours by some half an hour per week using the ACS data, and is reducing the probability that women are working in part-time jobs. And also to go a little, I mean, this half an hour a week might look a little bit small, but then we also did a similar analysis with the ATUS data on how much time women report to be working. We have information, even though the ATUS only asks one spouse at a time, we have information by linking it to the CPS on what their spouse is working on. And we see a large increase of women being working 5 to 10 percentage points, a larger fraction of their day towards the end of after the pandemic period, which a day has 24 hours, that's around 1 to 2 additional hours per day according to our estimation. Now we have a lot of tests that we have made to try to sell the point that this is something that has to do with work from home specifically. We don't have to talk about all of this, but we will be happy to discuss. But if there's one thing that I would like to highlight, is just the first bullet point here. Like we said, our betas are identifying the spillover and the matching effect, so we wanted to try to distill that. And one strategy that we had was we got inspiration from Emma's paper on using the college degree major level shocks, like how does work from home uptake change at the college major level, with the idea that this kind of shock at the women's college major level, with the idea that this kind of shock would be able to capture the probability that the woman herself works from home. So when we take that shock and we interact it with our spousal shock, we should be able to separately break apart the correlation between women's own probability of working from home and her spouse's probability of working from home. And when we estimate this regression, what we see is that both effects matter, for sure, the direct and the spousal effect. And the spillover effect, we still see something similar, like around increasing, for example, the extensive margin result by some 1 percentage point. Now, let me talk about time use and household specialization, results that we find. So the first thing that we find is that the spousal shock is increasing women's work from home uptake, which is to be expected since, as we said, we are identifying a matching effect. So, and that is bound to be increasing women labor supply because there have been previous work, such as Emma's paper in the US, or if you think more broadly, you can think about Lisa Ho's job market paper in India that shows that, yes, increasing remote work options for women naturally increases their labor supply. But then if women are more time at home, arguably, then you would think it's the same story as always, then they're also having to spend more time with the child. But what we see in our ATUS data is that, well, at the beginning of the pandemic, it does increase, we see that, but by 2022 and onwards, it doesn't seem to be increasing. If anything, it's slightly decreasing a little bit. But what we do see is that the man himself, hit by his own shock, or the men that are working in these high work from home, high change in work from home occupations, are taking on more childcare, specifically while working. Around an additional 1 hour of their day that they're working, they seem to be devoting it to taking care of the child, on average. And we also find a similar result to what Dimitri presented yesterday, that accordingly, households are also less likely to be hiring and overall spending less in money in daycare. And all of our results, when put together, we think that there is some evidence that remote work could be driving down the incentives for household specialization in the US by making a more equitable childcare arrangement, making households more likely to enter more equitable childcare arrangements, and increasing the women labor supply. That's about it that we have to present for today. Like we said, we're leveraging large changes in remote work options available to their women spouses to assess their own changes in women labor supply, particularly when they have young children. And we do find significant increases in women's labor market supply. And we do find that it is the availability of work from home specifically and changes in childcare arrangements do seem to be enabling these type of changes. Now I'll be glad to open up the space for questions.
So again, really great topic, cool paper. So the overall labor supply in the household's going up. Mm-hmm. So and they're using less childcare. So there's got to be something else that's offsetting. Now, part of it could be there's less time spent on commuting. But
we have results on commuting.
Okay, so,
yeah,
but it'd be nice to have an overall picture of your paper of the rebalancing of time use in the household, because the household's spending more time in work. It's not clear whether they're spending. Well, it sounds like they're spending more time in childcare as well, because they're purchasing less from the outsider. But there may be efficiencies in monitoring the kid while you're working. So that's less clear. But just some overall picture of the time reallocation.
That would be amazing. I guess part of the difficulty on that is that by construction, the ATUS only chooses one member of the household. So it would be amazing if we had the both of them to see. So yeah, we're trying to make a story with what we have of there being some childcare arrangements. But yeah, it's true. It's true. I agree, and that's a bit of a limitation.
Yeah. So let's do one question and then move on so that.
Okay. Thank you so much. This is so interesting. I think as I think about this topic a little bit more, I think more realistically is not one person shocks the other person. It's like the household jointly make decisions, right? So I think in the future, a promising direction would be to model this joint decision simultaneously rather than using one person's occupation change to shock the other. Just like a little comments on your ACS analysis, because I also use this kind of data. I think it's quite important to include the interaction terms between women and their men's education with time dummy, because that will relax some of your parallel trends assumption.
I have done that, and we survived that analysis. I don't know if we have more time, but yeah, we should be modeling that, and we're thinking of steps to do that. There's a practical reason why we use the spousal shock as well. We are interested in finding the extensive margin outcome, right? So if I were to use women's own education or women's own occupation, then I would be conditioning on a sample that is already working, because if they're only going to ask you your occupation if you're working already. So that was part of it. Also, a nice little trick to be able to identify the extensive margin outcome. I think Emma also discusses it in her paper.
Thanks very much.
Thank you.
Good morning, everyone. My name is Octavio Aguilar. I am a first-year PhD student at the University of Michigan. Thank you to the committee for including me in the program. I'm very happy to be here. And this is very much a work in progress, so I'm very open to all types of suggestions and feedback. Okay, so there's two motivating facts behind the research project. And the first has to do with this historical rise in disability employment post-pandemic that's been driven by rising labor force participation. And the second fact has to do with that the almost entirety of this increase in disability employment can be explained by work from home. So in this paper, what I want to ask is, how has this rise in work from home among individuals with a disability affected industry productivity? Okay. So to do this, I combine industry-level productivity data with a shift share measure that captures differential exposure to this rise in work from home among individuals with a disability. And what I find is suggestive evidence that this rise in work from home is associated with year-over-year productivity declines ranging from 2% in 2021 to 4% in 2024. So for data, I'm using two public use data sets. The first that we all know about is the American Community Survey, using their transportation to work question to have information on work from home. And they also have information on disability status. And then second, I'm using the BLS industry productivity data, which is going to give me information at the annual level on total output, output per worker, and output per hour. So I'm going to construct a panel of 4-digit NAICS industries from 2016 through 2024. Now for the definition of disability, the ACS has a set of 6 questions that can be used to identify individuals with a disability, and they're shown on screen now. And following prior work, I'm going to focus on the set of physical disabilities, which are shown in the first 5 bullet points. So I'm not going to include a cognitive disability in my definition, which I'll talk a little bit more about in a few slides. So for the identification strategy, recall my goal is to identify how industry exposure to this rise in work from home has affected productivity. So my approach is I'm going to leverage 2 sources of variation to create a shift share variable. So this first source of variation is going to be these exogenous shifts or changes in work from home that vary substantially across occupations. And then the second is going to be the fact that occupations vary in their distribution of industry employment. So equation 1 is showing how I formally construct the shift share variable. So I'm taking the inner product between these changes in work from home at the 3-digit occupational level and the industry occupation employment shares, which are essentially weights that sum to 1 within industries. And notice the superscript D, so everything in every object is disability specific for workers with a disability. Okay, so just to take an example of what exactly is going on here, we could look at software engineers, take the change in work from home between 2019 and 2022, and then weight this change depending on how many software engineers there are, say, in the computer systems and design industry. And then summing this measure across occupations is going to give me an industry level measure, which I call work from home shock. Okay? So industries are going to be more or less exposed to this work from home shock. And it's somewhat intuitive that these high exposure industries include computer systems design, software publishers, and these low exposure industries include child daycare services and restaurants. Now, my main identifying assumption here is going to be related to these shifts and changes in work from home. And following the same assumption as Bloomdahl and Ruth, I'm going to assume that these changes in work from home are driven by supply and demand side factors related to non-disabled workers and not those with a disability. Okay. Now, before moving into estimation, I just want to quickly address 3 identification challenges. The first, as we all know, that there is this overall or universal expansion of remote work during the pandemic. So there could be concern that my shift share measure is capturing this broad expansion of remote work driven by non-disabled workers. So my solution here is I'm going to residualize with respect to non-disability work from home. And an alternative approach is I can just control directly for non-disability work from home. And then these second and third identification challenges have been flagged in prior work. The first is changes in the composition of the population with a disability. So this is why I'm not including cognitive disability, because there is a large inflow of individuals reporting having a cognitive disability post-pandemic, so about 1.5 million individuals. This is potentially concerning because these individuals could have more marginal disabilities relative to the rest of the population, and that could make them more employable, which could bias my productivity results. So I'm going to focus on the set of disabilities that don't drastically change pre-post-pandemic. And then the third concern is with this increase in labor market tightness. So to address this in similar spirit as Bloomdahl and Ruth, I'm going to control flexibly by including a third-order polynomial of non-disability employment at the industry level. Okay. With all that being said, moving into the relationship between work from home and labor productivity, what I'm going to do is estimate 2-way fixed effect event studies. Okay. So just breaking this down on the left-hand side, that's going to be the percent change in total output, output per worker, and output per hour in a given industry from 2016 through 2024. And then the main coefficient of interest is alpha 1, which is going to be recovered from a set of interactions between my work from home shock and a set of time dummies. So it's going to tell me the relationship between the work from home shock pre, during, and post-pandemic, and I'm going to be relying on the pre-trends assumption. And then everything else is quite standard, controlling for unobserved heterogeneity by including year, industry, and sector by year fixed effects. So again, the source of variation that I'm picking up on is within industry over time. Okay. And then the results are going to be interpreted as a 1 standard deviation increase in the work from home shock. Okay, so here are some of the main results. So here I have 3 panels, total output, output per worker, and output per hour. Okay, so starting with total output, there's no significant detectable consistent effect post-event. Okay. However, once we look at output per worker and output per hour, what we find is a consistent negative effect post-pandemic. Okay, so a 1 standard deviation increase in this shock is leading to a 2% decline in productivity in 2021, and that grows to around 4% in 2024. And so these are the residualized results. If instead I decide to control directly for non-disability work from home, the results remain consistent, which is to be expected. Now next, as an additional exercise, what I want to see if there's a specific disability category that's driving this negative effect. So here I'm re-estimating the regressions, but instead specifying 2 groups. So having a sensory disability, hearing/vision, and then in Navy, I have the self-care independent ambulatory disabilities. And the takeaway here is that there's not one disability category that's driving the effect. And then the last thing I want to leave you with before concluding is what the results look like if I compare individuals with and without a disability. So in red, I have the point estimates for individuals without a disability. And in blue is what we've been seeing up to this point, which is for individuals with a disability. And really what we see is that this universal expansion or broad expansion of remote work that's mainly driven by individuals without a disability leads to productivity gains over time. And what's being masked in this aggregate effect, and what I've pinned down, is once we isolate the disability-specific channel, we actually pick up on this negative effect post-event. Okay. And I'll conclude here just so we have time for questions. Thank you.
Great. So maybe let me start. And I think the elephant in the room is what is the mechanism here? Is it a measurement thing where we measure the hours of people who don't show up at the workplace differently, especially, or maybe, yeah, maybe especially, or maybe not especially, if they have a disability?
Yeah, no, I completely agree. I think for future work, I want to see if I can replicate these results using other data sets and also really think through the underlying mechanisms behind the productivity decline. But right now, I don't have a good answer for you.
I was guessing one thing is that isn't there a supply curve of, if you think there's a supply of people with disability rated by how productive they are, you make it easier to work, you move into that supply, so the marginal person coming in is less good than the improvement.
Yeah, that's a good point. That is one thing I had in mind.
Or there's a demand side as well from the employer that they're just slightly less matched. So I think in our stuff we don't see any effect on wage, because the big question is that the supply or demand side effect. Because supply side stuff, I think we see wages go down and as demand they go up, we see wages go flat. So
okay.
It's not clear, but you have a similar structure.
Okay.
There's presumably a distribution of how good people are, and anyone with a college degree, even though they're disabled, may be working.
I agree.
By the way, in the data, the typical person in this is like age 57 and has a walking issue. So people have an idea that in the data it's someone in a wheelchair. It's not. It's actually typically an older American that has some vision or ambulance.
I see.
Probably was working for 30 years, got a back problem. So that's just who most of them are.
Okay, that's very helpful. Thank you. Yes.
Yeah, along the same lines of Nick, the first part of Nick's comment, the simplest model I can think of that you could use to rationalize this result is one in which there's a competitive market. There's compensation for wages per efficiency unit of labor. Disabled people on average provide less efficiency units of labor services per unit time than non-disabled person. In that market, the wage differential between the disabled and abled people within a given occupation is the productivity differential. So then you could take that model, look at the wage differential, compute the implied change in industry level productivity associated with the shift, and do you get something remotely like the magnitudes you backed out from the industry level data? That's one way to evaluate a particular mechanism. It seems like the most obvious place to start.
Okay, thank you. That gives me a lot to look forward to and work on. That's a great idea, thank you.
I'd be curious to try to use this machinery to also think about industries that are maybe more exposed to the expansion of like women in the workforce, because there you might think they're a little less sorted on the basis of productivity. So it seems like maybe the effects are more ambiguous there.
Okay, thank you. I think I'm out of time, but I'm happy to chat after. Thank you.
So, good morning, everyone. Thank you for having me. I'm Nicole Barbieri, PhD candidate from the University of Naples, Federico II, and today I will be discussing about the role of working from home in shaping quitting behavior in the Italian labor market. I guess I must not convince you that COVID-19 accelerated the adoption of working from home arrangements. Perhaps what was contrary at that time to our expectation was this kind of persistence in the years immediately after the pandemic of this new way of approaching work. And this plot, just to say you that adoption and persistence involved the Italian labor market as well. In general, what I want to say about work from home is that it does not change only where people now are working, but has this potential to reshape, basically, workers' quitting behavior. And so, in other words, it can change how mobile they are into the labor markets. Moreover, by reducing the commuting constraints and the spatial friction, work from home could also change how sensitive quits are to wage. And why this is the case? So basically, traditionally, commuting constraints are able to generate friction into the labor markets, which results in a quit elasticity being less sensitive to wage differential. And so basically, when people have to choose whether to leave or quit their job, they must take into account, of course, wages, but also the commuting length that they have to face. And so the higher is this commuting length, the lower will be the quit elasticity, meaning that quits are less sensitive to wage differentials. Of course, work from home creates this unique scenario because as this can, in a way, can relax commuting constraints, and so can basically expand the workers' outside option, because now people are no longer geographically constrained to the local labor market, and so in principle can change how these quits are sensitive to wages. And so what actually I want to ask for this project is whether work from home, first of all, can shape in a way workers' quitting behavior, and how can this effect translate into changes in workers' quit elasticity. Of course, when you're trying to answer this kind of question, you must deal with the endogeneity that arises from the self-selection into work from home adoption. So basically, people choose work from home because of some unobservable characteristics that can simultaneously affect their workers' their mobility decision. What I do is basically to rely, instead of the actual use of work from home, on the potential that each occupation have in order to accommodate for a remote option. And so I'm going to basically exploit these occupational differences in work from home feasibility in a difference setting in order to identify the causal effect of work from home on workers' quit behavior, voluntary quits, and quit elasticity. So, as I said, I rely on this potential for work from home. So I'm going to use this potential for work from home in order to define my differences setting treated and control groups. But then I also have a look at the actual use of work from home just for the descriptive purpose in order to see the incidence of the actual use of work from home across the Italian sectors and occupation, but importantly, in a way to validate the teleworkability measure. So I want basically that the teleworkability classification is able to predict the actual use of work from home after COVID-19. And then I draw data on an Italian administrative data set that basically allows me to track job-to-job separation. But importantly, I can observe why this kind of separation happens. So I can see whether this job-to-job separation are due because of voluntary resignation or quits, which is crucial in order, because this is my main variable of interest in this setting. So first of all, as I said, I want to validate, in a way, this teleworkability measure. So I want to see whether teleworkable actually means the real adoption after COVID-19 of work from home. So I'm going to run this specification where on the left side I have these dummies, which marks whether an individual is going to declare to be in work from home adoption in occupational at time t. And then on the right side, I have this teleworkability measure interacts with the years dummies. And while controlling for occupation sectors and time fixed effect, basically the coefficient that is going to be estimate is going to tell basically how much teleworkable jobs are likely to actually adopt work from home after COVID-19. And it seems to be the case, so that basically we observe that there is this sharp increase in the actual use and the real use of work from home among occupation who are defined and classified as teleworkable ones. So once I validate this measure, I use it in order to see what is the effect of teleworkability on the workers' quitting behavior. And so on the left side here, I have dummies, which marks whether an individual is going to voluntarily leave his employer at time t. And then on the right side, have again this teleworkability measure interacted by years for each dummy. And then I control for individual, occupation, region, sector, and times fixed effect. And so the coefficient that is going to be estimated here is going to tell me how much those in teleworkable occupation are likely to voluntarily leave their employer. What I found is that after COVID-19, it seems that those who are in teleworkable occupation overall are less likely to voluntarily quit, and so are less likely to voluntarily leave their employer. And these results, is in line with the idea that now people are happy with this new kind of flexibility. And so when employer is providing you this work from home option, the probability of staying with your current employer is higher. So that's why we observe that those who are in those kind of teleworkable occupation actually are less likely to voluntarily leave their employer. And so, in a way, work from home is a tool that can increase the attachment that you have now with your employer. But of course, this does not mean that when the wage are changing, then these results is the same. So in a way, this means that, people in teleworkable occupation now can also find a new job in other labor market, and so can become more sensitive to wage differential. And so in order to see whether, those in teleworkable occupation actually are becoming more sensitive to wage differential, I estimate this quit elasticity, and I estimate this quit elasticity modeling the probability of having a separation as an instantaneous separation rate that can potentially happen in a given interval of time, and it is a function of some controls, like observable controls. And the feature of this kind of model is that when you use when implemented through a complementary log-log model, basically the coefficient beta that is going to be estimated can give you the direct estimation of the quit elasticity. In general, higher quits are associated with lower wage. But what we observe is that after COVID-19, it seems that the workers are becoming less sensitive to wage differential. But in general, this decline is less pronounced for those who are in teleworkable occupation. So suggesting that actually those in teleworkable occupation remain more wage sensitive after COVID-19 relative to those in non-teleworkable ones. So overall, what I found is that those in teleworkable occupation are less likely to voluntarily leave their employer, However, after COVID-19, there is a decline in the quit elasticity, but this decline is less pronounced for those in teleworkable occupation. So in a way, work from home actually allows increase, let's say, the attachment with your current employer. But however, when the wage change, it seems that those in teleworkable occupation are more likely actually are more sensitive to these wage changes, and that's because basically also an employer can offer you this kind of no-wage amenity, and so you are basically becoming more sensitive to wage differential. In a way, work from home may have protected workers for this, let's say, decrease in the elasticity after COVID-19. So what I studied so far is that work from home has, the impact of work from home on voluntary quitting, and then on the quit elasticity. And what I found is that those in teleworkable occupation are also those who are less likely to voluntarily leave their employer, but those in teleworkable occupation remains also relatively more elastic after COVID-19 with respect to those in non-teleworkable ones. So in general, the main takeaway is that, of course, work from home has this kind of potential or reshape, in general, the employer-employee relationship. So that's it. Thank you.
So in the models that rationalize the quit elasticity with respect to wages, it's not obvious to me that those models would imply a linear empirical specification.
Yes.
And so I would think that if you're getting a high wage relative to your job and person type, you stick with it. And if you get a low wage, and the lower the wage is relative to that benchmark, the more likely you are to quit.
Yeah.
And that logic suggests that instead of the kind of linear in the wage specification you have, and you have fixed effects to control for like the mean wage and the occupation and so on, that you'd actually want to construct measures that are the wage deviated about the say the mean for that person's occupation experience and so on, and look for non-linearities, in particular a differential response to wages above or below.
Okay.
So, but I don't know this literature very well. When people explore this, do they typically work with linear specifications?
In general, in order to have like a direct estimation of the quit elasticity, you should have an exogenous variation of wage, which is quite difficult to have in reality. So one way is to model, let's say, this kind of, the elasticity through this kind of model. Okay, so it's like if you have you basically are modeling the probability of having a separation condition in a given interval on time, conditional that this separation is not happened yet. And so it's a function of this kind of control. So it's you are modeling basically this probability as an hazard model. So when you take basically the derivative of that function with respect to wage, you get basically an insight on how much should be the elasticity when the wage is changing.
So I think one meta question from your paper is how much is what you're capturing a transition effect from the few years after the pandemic, and how much of it is going to stick around for the longer term? And so I think maybe labor markets in your setting were less messed up in the wake of the pandemic than say in the US, and so that can alleviate some of those concerns, but I think more data from later periods would be very helpful.
Okay, thank you. But I guess it's something that, for sure, maybe I'm capturing this kind of transition, but I guess one way to deal with this issue is to take the teleworkability of the individual before, COVID-19, and maybe in this way you can deal with this problem of transition, because it's now the main problem, I guess, is that now you are maybe you are leaving your job because now your occupation is teleworkable.